All right. So my apologies for having already worked out this one. I recorded this part of the video, and then I realized that my microphone was not turned on when I was doing the screen recording. So this one's already kind of filled out. I'll just be walking through it with you. Sorry for the inconvenience. I'm not immune from technical difficulties, so sorry about that. The rest of them are worked out in real time. This one is just kind of presented, and I'll talk through it with you. Okay, so what we're doing is we're considering the preferences of our bundles represented by this utility function. So this utility function is 3x plus 2y plus 5. So first, we recognize this is a perfect complements. Sorry, no, not perfect complements. This is perfect substitutes. Perfect substitutes utility function with the following form. I left off 5. So there's a 5 right here. Okay. These are perfect substitutes. It just means that we substitute between x and y perfectly. So what does that mean? When we're finding the marginal rate of substitution, which is defined as the marginal utility of x divided by the marginal utility of y, when we take the partial derivatives of the utility function, this is going to be 3 over 2. Because the partial derivative of this with respect to x is just going to be 3. The partial derivative with respect to y is just going to be 2. So we see that this is a constant marginal rate of substitution, and it's not decreasing. So this suggests that we have a boundary solution. So it's either going to be the case that the consumer buys only x or they buy only y. They're not going to really buy in between. So what we first want to do is we want to suppose prices of the two goods. So that's part A. Now for part B, we want to suppose prices are px is equal to 2, py is equal to 5, and their income is 20. So first we want to draw the budget line, and then we want to find the optimal choice. So here, for part A, there are the indifference curves. And we got the indifference curves. For perfect substitutes, they're going to be straight lines. And the way that we can kind of solve for these, sorry, when I did it earlier, I did not have the plus 5. So when we want to solve for y in terms of x, this will allow us to plot the indifference curves in a bit of an easier way. What we do is we just isolate y on one side of the equation, divide over by 2, and then we get the slope of the indifference curves. Sorry, we get the form of the indifference curves. We can plot those here. We're just looking for a line that's downward sloping and has a slope of negative 3 over 2. We just plot this for different utility levels, and then we get our indifference curves. Okay, now we're on part B. So the equation for the budget line is going to be px times x plus py times y equals m. So when we plug in those values, we get 2x plus 5y is equal to 20. So now we want to draw this budget line. Yeah. So I can rearrange this. I get 5y is equal to 20 minus 2x, and I divide over by 5, and I get y is equal to 4 minus 2/5 x. Okay, so this is another equation to represent the budget line. I'm going to plot that on the same graph. So again, the budget line is 4 minus 2/5 x. So this is the budget line. Just kind of a rough drawing, but you get the picture. It is a slope of negative 2/5. So now to find the optimal choice, what we have to do is we have to recognize for perfect substitutes, if the marginal rate of substitution between x and y is greater than px over py, we will buy only x. Conversely, if the marginal rate of substitution is less than px over py, we will buy only y. So this is kind of the rule of thumb we use here. This is the rule for perfect substitutes. Here, we just plug in px and py. We found the MRS in the previous step, and we just compare them. So here, px is 2, py is equal to 5. So this means that the px over py is just 2/5. I just plug those numbers in. And we want to compare this to the marginal rate of substitution between x and y and px over py. So the marginal rate of substitution is 3/2, like we found in the previous part. This is greater than 2/5. This is greater than px over py. So this means that we will buy only x. Okay? So this means that our optimal consumption of x and y at these particular prices is going to be m over px for x and 0 for y. If I substitute in these values, I get 10 as the demand for x and 0 as the demand for y. So if I plot this on this graph, I will have to draw another indifference curve up here, but we can see that this is going to be the utility maximizing choice of x and y. So this one right here is our optimal demand. Sorry, this indifference curve doesn't really fit on the graph as drawn. I hope you'll forgive me for that. Okay, now what we want to do for part C, I'll scroll up so you can see it. We want to suppose that py and m are fixed. Then we want to obtain the optimal choice of x and y as a function of px, as well as we want to find the demand curve. So two things: we want to find the optimal choice as a function of px, and we want to find the demand curve. Now, fortunately, we've already done most of the work to get here. We found what the demand for x and y will be, given fixed prices. Well, actually, we know that whenever the MRS is greater than xy, is greater than px over py, we'll buy only x. And if the MRS is less than px over py, we'll buy only y. So this will change for different values of the price of x. If the price of x is really low, and we're here, then we'll be buying only x. But if x is like 10 million or something, the marginal rate of substitution, which is only 3 over 2, is going to be less than px over py. So this means, in that case, if the price of x is too high, we'll only be buying y. So we kind of plug in py is equal to 5, m is equal to 10, and we treat px as the variable. So using that previous rule, we have that if the MRS, which is 3 over 2, is greater than px over 5, we'll buy only x. Conversely, if 3/2 is less than px over 5, we'll buy only y. So we can simplify this condition. So 3 over 2 is greater than px over 5. Simplifies to just px is less than 15 over 2. This, in other words, this is 7.5. So if px is less than, I'm just going to write it like this, 7.5. If px is less than 7.5, I buy only x. Since my income is 20, and the price of x is here, the total amount of x I can buy is 20 over px. Again, this is only for when px is less than 7.5. Because when the price of x is greater than 7.5, I only buy y. This means that I demand 0 of x, and my income divided by py is how much I buy of y. So I buy 4y if the price of x is greater than 7.5, and I buy 0x. However, if the price of x is lower than 7.5, I buy only x, and my demand for x is 20 over px. My demand for y is 0. Okay, so what I do first is I look at this, I basically plot this, treating px as the independent variable and the demand for x as the dependent variable. So if we look at how I get this, at, I'm just going to write 7.5, just to be consistent. So at 7.5, I switch from buying a positive amount of x right here to buying a negative, I'm sorry, not negative, a 0 amount of x. So my demand goes from here, where I'm buying a positive quantity, to buying 0. As the price of x decreases, so as the price of x goes to 0, the amount of x I buy increases like exponentially. It grows at a very fast rate. So as I decrease the price, the amount of x I can buy increases very fast. Once the price of x increases past 7.5, I just buy 0x. So this is kind of the opposite of the demand curve. This is the flipped curve. What we want to do is flip this to find the demand curve as we usually refer to it. So I'm going to kind of zoom in a bit just because I'm running out of space here. So the demand curve, So what I do is I just flip this graph. I'm going to plot x on the horizontal axis, px on the vertical axis. So to do this, I note that when the price of x is greater than 7.5, demand for x is 0. Once the price of x equals 7.5, I jump up to here, this point. And then as the price of x goes down, the amount of x I buy increases. So this is my demand. For x. Yeah, so I plotted it down here. It's the same thing. The way that we can do this mathematically is we note that x is equal to 20, so my income, divided by px, when the price of x is less than 7.5. So we rearrange this and solve for px as a function of x. So the price of x is equal to 20 over px. Sorry, 20 over x. Then what we do, to get like this value right here, we set x equal to 20 over the price of x at the point where we switch. So this is just simplifying. It's 20 over 15 times 2, which is 8/3. So my demand at this particular value of the price of x is 8/3. And then it just increases as the price of x decreases. So yeah. Now, finally, what we want to do is we want to fix px is equal to 4, py is equal to 1. Then we want to express the demand for goods x and y as a function of m. Then we draw the Engel curves and determine if good y is inferior or normal. Okay, so a lot of tasks to do. Okay. So when the margin, we know that the marginal rate of substitution between x and y is 3/2. When the price of x is 4 and the price of y is 1, px over py is equal to 4. So here we see that the marginal rate of substitution is less than px over py, so we will buy only y. This means our optimal choice is going to be m divided by the price of y for y, and this means that we'll buy m units of y and 0 units of x. So the Engel curve for x, we see that at any income level, given this particular set of prices, the demand for x is going to be 0. So the Engel curve, I can draw it. So we're going to plot x here and here, and the curve is just going to be here. Right, so this is the Engel curve for x. It's not very exciting. It's a vertical line. It basically just means x is equal to 0 for all n. Okay, now what we want to do is we want to plot the Engel curve for y. So what we want to do is we want to express y as or m as a function of y. Well, we know that at any income level, we're just going to be demanding m units of y. So this means that this is literally the Engel curve. So for any level of m, we buy this many units of y. So this is my income, this is how much y I buy. What we could do is we just, plot y as a function of m, then we flip it to get this. But in this case, it's a straight line, so it's literally the same. But this is the Engel curve for y. And just note that we're plotting y on the horizontal axis, m on the vertical axis. And we just got that by plotting it the other way and just flipping the graph to get this. Okay. So the last thing we want to determine is if y is inferior or normal. So good is inferior if the amount you buy decreases as you get more money. So the partial derivative of y with respect to m is going to be less than 0. Now, if it's a normal good, then the partial derivative of y with respect to m is greater than 0. Intuitively, the more income you have, the more of it you buy. So here, we just take the derivative of y with respect to m. We can set that's 1. This is greater than 0, which implies that y is the normal good. Okay, thanks for watching.